So in this video, we're going to create a program that's going to have ID and OD work. And to start it, and it's going to look like this, we're going to go right into the O list, and we're going to start a program number in this case. My C number 6 is open, so I'm going to use that one. So I'm going to go into the new button, which will open up menu or window for me to start typing in the name I want to call it. So I'm going to use the typical Fanuc formatting, which is letter O and then 4 digits, 0006. I'm going to hit create. So now we have number 6 in there, and then I'm going to give it a name. So go into edit comment, and let's call this, since it's ID/OD work, let's do our I, and then Shift D, space O, Shift D. Now, granted, you could put numbers in there if you had a print that had actual drawing numbers. You could put that in there also. So I'm going to hit Alter to accept. So number 6, ID/OD. And then I'm going to hit Open to open up that program. Okay? At this point, I'm going to go to that right soft key, and what we're looking for is this menu here. We got Start, Cycle, and End. So first thing we're going to do is go into the Start menu and give it the blank information. So I'm going to tab over to blank and then come down. I have a selection. Either I can do the cylinder blank figure or the hollow cylinder blank figure. In this part, we're going to assume that the 1-inch hole is already there. So we could go into the cylinder, hollow cylinder blank, go down to this one, select that, and numbers are already there since I played with this one before. But the outer diameter is going to be 7 inches. The inner diameter is going to be 1. My length, I'm going to go somewhere past, this 3.25, so probably 5 inches would be good to get in. This is just so we can get it on graphics. And then the last one is work origin. I'm going to leave that at 0.1 because we're going to end up using a facing operation for cleaning up the face. I'm going to insert that in the part program. So we have the blank already in there, and just want to mention the blank has nothing to do with the completing the part or machining of the part. It's for visual only. So at this point, we can go into tool change, and we're going to go back to that start menu, and we're going to tab over or arrow over to the tool call. And then, this is, again, a specialty tab that only Harrison has, and they worked with Fanuc to create it. But it makes it more of a conversational fill in the blanks, that type of thing. So I'm going to open that up. And tool change position. This is somewhere back away from the part, so I'm going to do X of 12 and Z of 10. And then the TC approach method is how the axis pattern is going to get there. So in this case, it's set for X first, then Z, or we can do Z first, then X, or 2 axes. So it really depends on what you have to get around. I'm going to leave it with X first and Z, because I'm going to have nothing in my way because I'm out here to actually rough the OD of this thing. So the next thing I'm going to have is what tool number we're going to use. And so I'm going to select tool number 1, and it's 101 for tool 1, offset 1. And then the start position, X, is approaching back down by the piece. We're going to leave a little bit of clearance because the cycle itself will bring us in closer. So I'm going to tell it to come down to, let's say, 7.1. 7.2 would be sufficient, and Z of 1 inch. Again, it's just a clearance position. Okay, return method reverse on or off by these selections here. So how we selected to go to tool change, which is X first and Z, If we have the reverse method on, it will do Z and then X to get back up to the part. Okay, so again, the ability to get around things. If I got a shoulder in the way, or if I'm working ID, I want to get up and over. That's how we can use this to our advantage. All right, we're going to keep that one. We'll hit input. It'll go to the next tab, and that one is going to be setting of the spindle. So obviously for a 7-inch diameter, we're going to slow that maximum RPM down. Let's do 1200 RPM. Oop, not that much. So 1200. And then my spindle speed is relevant to what I use down here. I got CSS active, so this could be, let's say, 500 surface feet a minute. In the forward direction, again, I said CSS, so it'll have constant surface speed active and coolant on or off. So that one is down here, on, off for second. I'm going to leave it off for now. The next tab, we don't have to worry about, because with a tool post, the thing will come back and stop anyway to, you know, shut the spindle off and allow you to open up the door and change your tool out. So I'm not going to put anything in there, and I'm going to hit insert to put this into the part program. So we got up to the point where we've got the program number created, the billet information, and the tool called up. So first thing I'm going to do is, you know, if you've got someone else's saw, not one of ours, you would have to face this off because it's all crooked, okay? The billet is. So this is, I'm going to do a face cycle over that 7-inch and get it down to a clean surface all the way down the face. So what I'm going to do is I'm going to activate the a cycle to do so, and that's going to be a facing cycle. So I'll go into cycles and then go down through it. You know, I got face rough here, but I'm going to do a face rough and finish. Nope, not that one. It'll keep going down. So that's the one I want. No, let's try that again. This one here, face rough and finish. So I'm going to select that, and I'm going to start filling in the information on how I'm going to attack the part. So I'm going to attack it in the X minus direction, you know, so I'm facing it off this way. So my cut depth is my next thing, and that I'm going to put that a little bit less than what I normally would, but I'm going to put that at, let's say, at 50 thousandths cut depth. And then that'll be per pass. And then my rate of cut depth, it's a Fanuc bell and whistle that they put in there to, or enhancement if you want to say, to take less per pass as it's moving in. I'm going to leave it at 100%. Because if I change that to 80, it'll take 20% less for the first pass, and then next 20 less and 20 less. The X-axis amount, I'm going to leave for a finish. If I want to leave for a finish, I could put that in here. Being I'm facing off, and assume that the part actually had that bore in there of 1-inch diameter. So all I have to do is get below 1 inch when I draw this up, but I'm not going to leave a next finish. So I'll just put that at 0, or leave it out because it's an asterisk, so I don't have to put anything in there. But the Z-axis finish, I want something because I want to have some material to clean up and give it a good finish. So let's put the Z at, since we're cutting in the X minus direction, we can put that at, you know, 10 to 15 if we wanted to. Okay, then the cut direction feed rate, which is the feed rate on going at the part, I'm going to put that on the roughing side of it. Let's do maybe 8 to 10, somewhere around there. Oops, not that much. So let's go with that. And then my cut depth feed rate, which I have no re-entrant shape on the facing cycle, but because there is no asterisk on this one, I have to fill it in. I may have forgotten to bring that up, but anytime you have an asterisk, you don't have to fill in the information. So let's at least give it a small value of 3 thousandths per rev. And then my cut rise is coming back out of a reentrant shape, which again, no reentrant. I could leave that at 0 or nothing in there, but I'm going to put it back to 8 for that. Finish feed rate, let's do 5 for the finish. Now, then it goes to the next tab, which is details. And that's first thing, another enhancement from Fanuc was first feed override. So the part is really out of flatness. You may want to slow that down for the first pass. You know, so we could put that at 50% if we wanted to. So it would cut my feed rate down to 50% on that first swipe, and then kick back up to 100% on the feed rate for every cut after that. I'm going to leave it at 100% in this case. And then cut rise is how I want to take the pass. The speed cut difference, again, would be that at the end of the cut, it would come off on a 45 degree, shoot back out, go in the next cut, and start cutting. I'm going to leave it cut rise to kind of follow the contour. Either one isn't going to matter at this point. I'm just facing it off. And then whatever the cut rise, if I select that, this escape amount is how much it's going to fall off. That same as a speed cut, it will come off by 50 thousandths. And then on the clearance, this is the clearance from the end of the piece. And it's going to be 1550, so I don't wrap it right into the corner of the part. Leave that there. And then how do I want to get there? And again, remember, this is coming from my clearance position, so it's going to do Z first and then X to that clearance position outside the piece. It doesn't know it yet, because when I develop the contour or the actual facing cycle, it will put that in relationship to that facing dimensions that I'll have. So when we get this done, we'll insert that in the part program, and then another screen will come up to actually develop the shape of it. So I put into the program how I want to attack the piece, and now it went to the what I'm going to call is the drawing editor. So you can actually draw up the surface or the finish pass is what it is, on how you want to take this cut. So the start point on this is actually going to be outside that 7-inch diameter. So we could put it at 7.05 if we wanted to, and then the Z start point, because I'm developing the finished pass. So I'm going to take this down to Z0. I'm going to imagine that you know, the extra material is beyond Z0. So and I'll draw that up accordingly. So I'm going to have that as my element start, and press OK to accept that. And now I got a starting point that is being shown there. And then I'm going to do a line move, and I'm going to go line up. In this case, because of the way the flatbed is laid out, it's going to cut in this direction. So my end point, and I mentioned that earlier, that, you know, we're assuming that we got a 1-inch hole in there already. So I'm going to take the X dimension to like 0.9, something smaller than what this 1-inch diameter is going to be. The other stuff we don't have to fill in, because we're not trying to calculate out tangent points, so we can leave that in there, and it is still part that I'm drawing. So I'm going to select OK to accept. So now I got a line going up to X of 0.9. Then I'm going to do another line coming off the piece back to this. And what you're developing here is how much material do I have to take off. So if I got 300 thousandths of run out, I'm going to start this thing out 300 thousandths, and you'll see what I mean by that. So I'm going to put it in your 0.3, and then select OK. So this is back and back off the piece. And again, this is the finish pass. So at this point, I need to square this thing off. And to do so, I'm going to select the left-hand key over here until I see this. So I'm going to select that. And then select number 1, because that's what I actually want to do, is start from that corner down there. So, and then, is it a connection? Blank as connection? Yes. So the roughing, because I squared this off, this roughing will start from that corner, the Z of 0.3 and X of 7 inches out, and then feed its way over and up to remove all that material. Once I have that done, I can just hit create and it'll actually load that into the part program. So once we get the facing in there, we don't have to recall up the tool to start roughing the OD. So we can go right into another cycle, and then we're going to select outer rough. Because I want to split up the roughing and the finish pass, because I want to rough both OD and ID before I finish either one, in case my part shifts on me. So I'm going to select outer rough, and we're going to go into Z minus direction. Cut depth, let's put it at 0.1. Rated cut depth, we'll keep that at 100%. Finish amount, we'll leave, let's say 30 thousandths, and again, that'll be for later when I come back and do the finish pass. Z-axis finish, we're going to put that at about 3 thousandths. Cut direction feed rate, that's your normal cutting feed. We'll put that at 12, and then we're going to do cut depth feed rate, which is a reentrant shape, which we don't have, because that reentrant shape that shows up there is going to be done with a grooving cycle. So, but I got to give it something. We'll give it 3 thousandths, and then the cut rise feed rate, I'm going to leave that blank since it's not going to be used. When I hit input, it's going to go to the next tab. Okay, that one, first feed override, we'll leave it 100%. We're going to use the cut rise method and not the speed cut, which is your selection down here. Cut rise will follow the contour out to the escape amount. It blends it better, so that's why I want to stick with that. So we got 50, 50, and 50 in there. Now the approach motion is from the, when I did the tool call, I came down to the part out here, got done with the facing, comes back to there, and now it's going to go from there to the start of the cycle for the roughing. So it's at Z first and then X, which will be fine either case because I'm outside the part. So I'll insert that in there. So once we create the parameters for roughing it, it comes up with the drawing editor or figure. So we're going to start typing those numbers in for that to show the finish pass on that. So we're going to start X at 5-inch diameter and then 300 thousandths on the chamfer total. So let's go to 4.6 and then Z of 0.05 just off the face, and then we're going to put that in there, and then we're going to do a line move to come over to the face of the part. So we're going to hit left and Z of 0, and we're going to go with that, and then another line move, and now we're going to start working our way around this thing. So we're going to do a line down, and X is going out to 5-inch diameter. Select OK, and then before it gets there, we're going to throw in this chamfer. So we're going to do corner chamfer, and chamfer size is 0.15 based off the print, and then select OK. Now it doesn't show it yet because it doesn't know which way we're going. So we do another line, and now we're going to go from that point over to the end of that move, which is 1.5 back off the face. So we're going to go to the left and then minus 1.5, and now the chamfer shows up. Next move is going to be, because that diameter is the same as the end point right there. So next move is going to be a line, but in the left down, and that's going to X of 6-inch diameter and Z of minus 2.1. And select OK. So we got our angle line there. Now we're going to come straight back to the Z endpoint of 3.25. Select that. Whoops. Alter. Forgot the minus sign, so we'll put that back in there. That looks a lot better. And then at the end of that move, we'll do a corner radius. And the radius is 0.2. Input, OK. And again, it's not going to show it until we see the next move. We'll do a line move. And the line move is going to go down to X of 7-inch diameter. And before it gets there, we're going to pop in another corner radius of 0.2. And we're going to do another line move because we have to come off of it. We got to make a space for the 200,000 radius to get in there. So we're going to do a line to the negative of let's go 3.5. So that's beyond the end point of that radius. So we got that in there now. Now we're going to just come down off the part a little bit to X of, let's say, 7.05. Accept that. And then we have to close this thing out so it can actually rough it from an outside corner. So we press the left arrow key and then select the BL block. And we're going to go with number 1 and say yes. Okay, so we'll start roughing from there. Create that, that'll create it and put it in the current program. So at this point, you could run simulation if you wanted to. I'm just going to keep going because I'm going to start attacking the ID. We'll come back and run simulation a little bit later. So the first thing we want to do, because we are working on the ID now, we got to change the tool. So let's go to the Start menu and arrow over to the third tab where the tool call is and select that. And then we're going to tell it to go back to the tool change position. So X is going to go to 12 and Z of 10. And we're going to do X first, so it'll come off the part and Z over to the tool change. Call up the tool. Well, I set up tool number 5 is going to be my boring bar, so 505. And then this is telling it the approach back to the part. So what I'm going to do is I'm not going to come back over to the OD. I'm going to actually come back within the 1-inch hole. So not inside the part, but within that 1-inch diameter. So I'm going to do X start position of, let's say, 0.9. and Z of 1. Because when it's done making the cuts, I want to be able to get back to that 0.9 so I have clearance on the part when it pulls everything out. So we'll accept the reverse method, keep that on, and then the max spindle speed. So I'm going to put that, let's say, around 1200 RPM because we are working with a smaller ID. The nice thing about turning the OD first was to take off some of the weight. So if I do run faster on the ID, it'll be less of a problem because there'll be less weight on it. So the spindle speed, but this would be surface feet per minute because I'm in CSS. Let's put it about 600 surface feet there. And forward in CSS, and we're not going to bother with the coolant right now. So I'm going to hit Insert and to put the tool call in the part program. Now that I have the tool called up, let's go ahead and tell it what it's going to be doing. So we're going to go into Cycle. And now I'm going to come down to I'm going to actually select inner rough and finish because the OD is already rough. So I'm not having an issue of doing more work on that OD. So I can do the rough and finish with that same tool on the ID work. So you have your choice. You can do rough only and come back and do finish later. I'm just going to put the two together. So I'm going to select that. And then Z direction on my cutting is going to be the Z minus. The cut depth, we're going to put that, and again, this is going to depend on your tool itself. So how much push off am I going to get? You know, so I'm going to try 80 on that thing. And then rate of cut depth, I'll leave it 100%. X-axis finish amount, yeah, let's do about 25 on that. And Z-axis finish amount, again, we'll do 3 for that. The cut direction feed rate, or your normal feed rate, we'll put that at 10. And we don't have a reentrance shape because we're going to use a grooving tool, ID Groover, to do this undercut that we have in here. So I'm going to put that at 3 because I have to give it something. I'm going to leave the cut rise feed rate out, and then the finish feed. So let's put that at, let's say, 5 thousandths per rev. The first feed override, we'll leave it at 100%. We're going to use the cut rise method instead of speed cut. And then escape amount 50, 50 for clearance, and Z clearance of 50. So I insert that in the part program. Okay, so now that we've give it the parameters on how to rough it and finish it, we're going to actually develop the contour now. So X start point. Now before, when we were doing the OD work, we would go inside the chamfer and work our way out. Well, now that we're doing the ID, now we're going to come outside the largest diameter and then work our way in. So I'm going to start the X point at something bigger than 2.75. So let's go 2.85, and then Z of 0.05, and select that. We're going to go into a line move, and we're going to the left to Z0. Select that. Now, obviously, if you don't want to touch the face for any reason, just stop 1,000 short. You're going to stop at a Z of 0.001. That will work also. So now I'm going to do another line move, and then it's going to come up to, in this case I am going up the way that's laid out on this. So X is going up to 2.75. Okay, another line move, and we're going to do left up, and X we're going to 1.922. That's my bore diameter for the minor diameter for the bore diameter to put the threads in. So X is going to 1.922, and Z is going to a negative 0.5. Select OK. So we have that line in there. We're going to go to another line move, and we're going to take that straight back all the way to the minus 2.2. So we go left, minus 2.2, select OK. And then we're going to do another line move, and we're going to bring it up to the 1.5 on X, so 1.5 input, OK. And then do another line move. This is that for that angle, and we are going to go to angle left up, and we're going to go to X of 1 and Z of minus 2.625. And I'm not concerned about go ahead and boring that whole thing out. We're going to assume it's finishes well enough. So I'm going to just lead past the end point of that angle line. So I'm going to go to the left and minus, let's say 2.650 minus 2.65 input. Okay. And then I'm going to come off that surface a little bit. So we'll go up to X of 0.95 and select OK. Now we got to close that off. So we hit that left arrow key and then come back to this. And now we're not selecting number 1 as we would on the OD. We got to select number 2 because this is where I want to start the roughing from. So select number 2. And is it a connection? Yes. And then we can create that. Insert it into the current program. So now we are going to activate the grooving tool, and we're going to go to the start menu, go over to the tool call, the third tab over, select that, and now we'll send it back to X of 12 and Z of 10 for tool change position. It's going to take the approach of X first, then Z. Actually, we could do this the other way if we wanted to, so Z first, then X. Tool number, in this case, is going to be 6. And then the start position is the approach back to the part. And since I have reverse method on, X is going to go in first, and then Z will go to the start location. But I'm going to go to X of, let's say, 1.9, which is still smaller than the diameter of the thread. So. Or the ID of the bore. So I'm going to go 1.9 in X, and Z I'm going to remain out at 1 inch or 1 inch in front of the piece. The cycle will bring me in. Leave the reverse method on, and then let's put a max RPM of 1,000. And since CSS is, I can be using that with this tool, I'm going to put in surface foot per minute of 300. In there and insert the tool call into the part program. Now that we have the tool active or called up, now we're going to tell it what we're going to do with this tool. And so I'm going to go to cycle, and I'm going to tab over until I get to the T grooving. I'm going to come down to the inner rough and finish for that ID groove. So I'm going to select that. And then I'm going to use center cut instead of layer because it's not going to be that deep. So I just want to peck it to the diameter I want to go to, pull out, step over, and open up the groove. Side finish amount, I'll leave 2/1000ths on that, and bottom finish, probably 2/1000ths on that also. Remember, we don't have to leave too much because we'll have deflection, which is going to leave more material anyway. My roughing feed, let's do a 4 on that one, being it is a bar going down the throat of the part. And then my finish feed, I'll put that at 2. And like I said, I'm going to use pecking on there. And again, to change it, you use these icons. So I'm going to keep it on pecking. My peck depth, let's do 30 on that. And my rate of cut depth, I'm going to remain at 100%, and my return amount will be 5/1000ths. The next tab over, I'm going to have a clearance of 50, so it stays clear of the ID as it goes back in there to do the groove. And then we'll have a dwell of 0, and we're going to do approach motion of, I'm going to do Z first, then X. And then end cut position, I'm going to leave in the center. I got a choice. I can do center or corner. I'm going to leave it in the center. I'll hit insert. Now that this has come up, then I can actually tell it what is the figure of the groove. Inner trapezoidal was what I'll use because of the angle on it. I'm going to select that one. And then it wants me to pick where am I going to get this information from. And I'm going to do a Z minus because I want the X and Z to be in the back side. That's where most of my numbers are going to be based off of. So my base point X will be the 1.922 or 925. No, excuse me, 920 should be sufficient. And then Z base point, I'm going to leave at minus 2.2. My depth will be basically 64 thousandths, but I'm going to make it 65 only because I left my 2 thousandths off of there. So go L of 0.065. And my width, I'm going to take it off of the full width of the groove, so that's going to be 300 thousandths across the top, because that's what it's asking for, the full, from the top of the groove all the way over. I'm not going to worry about any corner radiuses or anything like that. And then the next tab, of course, is the information for the taper angle or width, depending on what we're going to use. I'm going to go angle, and the back side of that is going to be 90. And the front side angle is going to be 45. And there is no repeats, it's just one groove. So at this point, I can hit insert to put the figure into the part program. So now that we have the groove in there, we're going to go ahead and call up a tool for the ID threading. So we're again, go back to the start menu, tab over to the tool call, and tool change position 12 and 10, and the approach method is going to be, I'm going to change that to Z first, then X. Tool number, we're going to be going to 7 for this one. And then start position, again, back approach to the part. I'm going to go just something less than this. So 1.9 to be sufficient. Yeah, let's make that 1.8. And then Z of 1 inch. I'm still away from the part. Reverse method on. The next tab is going to be my spindle information. So I'm going to put this probably, we could probably do 600 RPM on that one, and max spindle speed. But I'm going to put those two the same because I'm changing the CSS to just direct RPM. So I press that icon and it changes that to RPM now. Once I get that completed, I'll insert that into the part program. Now that I have the threading tool called up, I'm actually going to pull up the cycle to do ID threading. So we're going to go over to the tab for the threading, come down to inner thread, select that one. And we're going to remain in the single A, so it'll be coming down to one flank, single side, and then each pass will be less and less as it gets down toward the bottom. And then the finish amount that we'll leave, let's say 2 thousandths. Number of finishing, we'll do 2 spring cuts. The cut type, we have a choice between number or depth. I'm going to leave it in depth, and then set a starting cut depth of, let's say, 8 thousandths. Let's try that again, 0.8. And then in this case, what we're going to do is from the approach point, because I went from tool change down to the front of the piece, and then I'm going to go from there, coming in X first and then Z to get into the start of the thread. And then my surface clearance on the thread after it pulls out of the pass is going to be 100 thousandths. And then my safety distance from the start of the thread will be 150. And then my exit clearance, I'm going to keep it at 0. I'm going to insert that into the part program, and then it pulls up the figure of what the thread is going to be. In this case, I'm going to stay with the general thread, and then it's going to be a female screw. My X start point is going to be 2.01. Now, it's showing it as the major diameter of the thread, so that'll make for the clearance of a 2-inch 12 thread. So 2.01, it'll probably have to be modified later just to make sure your go, no go goes in. Start point Z, being that the thread starts back here at a negative ½ inch, I'm going to have the start point at, let's say, minus 0.450. That way it's not cutting a lot of air time. The lead is going to be 12 threads per inch, so that'll come out to 0.0833. My thread depth is actually going to be 46 thousandths. My end point in the X, being it's a straight line thread, is still going to be at 2.01. And my Z end point, I'm going to leave it just short of that wall, which is at 2.2. So let's go minus 2.190. Okay, and then it's basically one thread. These two are for a multi-start thread, which we don't have that. So I'm going to insert that into the part program. So right now, what I have is I have the ID completely done. I had grooved it and I threaded it and I already finished turned it. What I had on the OD is that I just roughed it. I haven't done a grooving or a finish pass on that OD. So we're going to go ahead and attack that now. So the first thing I'm going to do is go back to my start cycle icon and go back to my tool call, activate that. And we're going to call up my finishing tool. So it's go back to tool change of 12 and 10. And the approach method, we're going to do Z first, then X. So Z will get out, and then X will come out to the diameter, or to the 12 inches. Tool number, in this case 2. So tool 2, offset 2. The start position of X is the approach back to the part. So I'm still going to use the, let's say 7.1 as a start position, still outside my 7-inch diameter part. So start position Z, I'll put it at 1 inch to maintain in front. The finish cycle will pull me up closer. The next thing is going to be my spindle speeds. So max spindle speed, we'll put that around 1200. We should never get there because of the diameter in the CSS that I'm going to run it at. So my surface feet per minute, that's what's going to go in here because of CSS. We can do that about 700 surface feet for the finish. Forward direction and CSS is good. The coolant will keep it off for now. So I'm going to insert that in the part program. So now that I have my tool active, I'm going to tell it to go in, or I'm going to go into the cycle, and I'm actually going to activate a outer finish. Highlight it, select it, and the cutting direction is still going to be in the Z minus in this case. And my feed rate, we're going to put it at, let's say 5 inches or 5 thousandths per rev. And X-axis clearance and Z-axis clearance 50 and 50, that'll be fine. The approach will be Z first, then X, because I'm out here, I'm going to just approach over and then start that finish pass. I'm going to insert that into the part program. Now, it pulls up this window to draw the contour, but I'm not going to do that. There's no reason for me to rewrite it because I wrote it for the roughing. So I'm going to cancel out. and then cancel again. Okay, now I got to go grab that finished contour. So I'm going to arrow up in the program, and that's the OD contour. And what I want to do is I want to copy from 1450, from G1450 to G1456. That's the start and end, as we can see down here, the start and end of the contour. So I'm going to go back one, and I'm going to hit copy, arrow down until I get to the 1456, put it to clipboard by hitting copy again, arrow down to the bottom of the program, because just above it is my finished call out, and then I'm going to hit paste. And that way it writes it all back down below the finish. And then at this point, it'll be a tool change time for my OD grooving. So once I have that finished profile put down in there, the next thing I have to do to complete the part is going to be putting in the OD grooving tool and call it up anyway. So go to the start menu, tab over to the tool call, select that, tool change position, and it's going to do X first, then Z to get to there, and tool number, in this case it was 303 for the grooving tool, and then start position, again, coming back to part, I'll remain at a clearance position, let the cycle pull it into the part, reverse method on, and then my spindle information. So let's do 1000 RPM. It'll never get there, but I'm just putting in a value. I can run the OD grooving tool with CSS. So in this case, I'm going to run it probably around, let's say 400 surface feet. And in the forward direction, and CSS is going to be active. Insert that in the part program. Now that we have the tool called up, let's tell it what it's going to do. Let's go to the cycle, and we're going to tab over to the grooving. And what we're going to do is come down here to outer rough and finish. We'll select that. And we're going to do center cut, because I want to peck this thing out and not do layer all the way across. And then my side finish amount, let's put that at 2, put the bottom finish at 2 thousandths. Rough feed rate, let's say 5 on that one, and finish feed rate of 0.003. Now it's selecting if we're going to peck or do nothing on it, just plunge right straight down to the bottom. I'm going to leave it at pecking. And then what is my peck depth? Let's put that at 50 thousandths for each peck. Rate of peck cut depth, we'll leave it 100%. Return amount at 5 thousandths. And we'll go to the next tab. And clearance is 50, which is fine, and dwell 0. I don't need to dwell down the bottom. Approach motion from out here to clearance, it's going to do Z first, then X to get to the start point of the groove. And the last thing on that page, we're going to tell it we're going to go to the center for the end position of the finishing. So we'll leave that at center and insert that into the part program. Once we do that, then it's going to come up with, okay, what's the figure going to look like? So we are going to have outer trapezoid, select it. Okay, where's our base point? Is it up here or is it back there? We're going to select Z minus, because that's where most of my numbers are coming from, is back in here, and with that too. So base point X is going to be at 5-inch diameter. That's what this diameter is here. Base point Z is at a negative 1.5. Okay, the depth of my groove is 100 thousandths deep. And the width of my groove is going to be 300 thousandths wide. It doesn't show that there, but I know that at 45 degree, that leg is still going to be 100 thousandths in addition to the 0.2. I'm not going to worry about the corner breaks until I get down to number 3. Let's put a little arc radius down in that back corner. So we're going to select arc and put in like 20 thousandths radius back there. And then the next tab is going to be my bottom width, or I can select on angle, how I want to describe the angle and taper of that groove. So in this case, it calls out 45 degrees, so I'm going to leave it on angle, put in here 45. And then the backside angle will remain at 90 degrees because there is no, according to this, it's just a straight line down in. There is no repeat, so at this point, I'm going to go ahead and insert that into the part program. Okay, so now that I've got the groove done, I'm going to actually call up my OD threading tool to complete the part, which is going to produce a 5-inch, 8 threads per inch thread on the OD of that. And so first thing I'm going to do is go into my start menu. Let's call up the tool, select that, and then tool change position, 12 and 10. It's going to do X and then Z to get there. And then tool call number is going to be 4. And the start position, that's just actually approach back to the part. I'm going to leave that at 7 and 1. Reverse method still on. And my spindle, I got to set that up. Now, remember when I'm doing threads, I'm actually going to run RPM. So we could put this at 800. I won't go that fast. And then spindle speed, I'm going to put it 400 RPM because I'm going to change this down here to RPM. Just like that. And then we can insert this into the part program. Okay, now let's tell it what that threading tool is going to do. We're going to go into cycle, then go over to the threading tab, outer threading, select that. Again, we're going to do the single A for how it's going to attack the thread. Finish amount, let's go at 2 thousandths. Number of finishing passes will remain at 2. My cut depth or number, I'm going to keep it in cut depth and tell it what my first depth of cut will be. And then from here, it will break it down so that each pass will be less and less as it's cutting the thread. Approach motion from out here in clearance will be Z first, then X. And we'll do a surface clearance of 0.1 and a clearance on the Z of 150 thousandths from the start of the thread. So we'll insert that into the part program. Once we have that in there, it will pull up the figure. We have to select what we want. So let's do the general, select, and then male screw. X start point is going to be a 5-inch diameter. Z start point, I'm going to put it at 0 because I have that 150 thousandths clearance in front of it. The lead, I'm going to put, this is 8 threads per inch, so it's going to be 0.125. And then my thread depth, we'll calculate it. So that's how deep each side will be. My endpoint X will still be at 5, and my endpoint Z, in this case, is going to be just short of 1.5. So let's go cancel. So 1 minus 1.49. Put that in there. And we're only doing 1 thread, so we don't have to fill out the last 2 bits of information. And then we're going to insert that into the part program. So we have finished running or creating a part program. What we're going to do now is just put in the end of the part program. A lot of you that may have done programming in the past, you put in M30, but in this case, this is something that Harrison and Fanuc developed. It's just a feature that they have for this machine only, for the XS brand. So I'm going to hit the end button and then arrow over to the next tab and select my end program information. And all we're doing is in here is just telling it where to go back to shut down. So I'm going to do X of 12 and Z of 10. And it's going to do X first and then Z to get there. And within this detail is the information of like M30 to shut it off, the program off, M5 to shut the spindle off, and M9 to shut the coolant off if you got that activated. So I'm going to insert that in the part program. And now that's in there. So at this point we're going to run simulation, and I'm going to push this button till I see simulate. I'm going to press that. I'm going to rewind to the top. I'm going to go into toolpath because of ID work. I want to go into toolpath to see it. I'm going to enlarge the screen. Let's do this, and then I'm going to move the screen around to be able to get it up there so you can see the whole thing. And then I'm going to hit start. So it's drawing the ID groove, it's doing the thread at this point, and then it's going to do an OD groove, and then threading the OD. So what I'm looking for is make sure I have no lines, red lines, dotted lines going in here, or my thread doesn't show up back here, because that won't be a good thing. So it looks like everything is good. So I'm going to turn the graphics off. And again, we're on the basis of, hopefully you've got the tool calibration set right, because the graphics doesn't necessarily pick up any type of problem in the tool offsets. So now that we have this done, I am going to now, let's say that you want to run it. What you would end up doing is closing your doors, and then you'd go into auto mode, and you would hit cycle start, and that part would run.